Hey there, Algebra 1 students. Today we need to continue talking about simplifying radicals. So, when we see something like the cube root of 12a over 512b to the fourth, oh, this is not just plain old a, this should be a to the sixth power. There we go. I'm going to break this up. I'm going to break it up a couple of ways. I'm going to put a cube root on top and a cube root on the bottom, right? If you have the cube root of a quotient, it is the same as the cube root of the top over the cube root of the bottom. And I'm going to break apart these guys. I'm going to factor them a little bit. Well, the 12 is just, if I factor the 12, it's 4 times 3, or another way to put that is 2 cubed times 3 times this a to the sixth. I'm going to break it into cubes if possible. So there's an a cubed and an a cubed. When those two are multiplied together, they give you a to the sixth power. Right? For 512, you might realize that the cube root of 512 is 8. I'm going to leave it as 512 for right now. B to the fourth, it will become b cubed times b, right? Because b cubed times b would be b to the fourth. And the reason I'm doing this is because I want to be able to take the cube roots of specific things and pull them out, if you will, pull them out of the radical. So the next thing I would do is notice, okay, the cube root of a cubed is a, and the cube root of a cubed is a, and a times a would be a squared. And so on top, I am left with a squared times the cube root of, I guess I leave it as 12. I multiply it back together because, oh, this should not be a cubed. That should be a squared. Sorry. 2 squared times 3. Yeah. So cube root of 12. We can't simplify that further, so it's going to stay that way. The cube root of 512 is 8. If you don't have memorized that 8 cubed is 512, you can use your calculator to see if that would work out. And it does. So that's what I did here. The cube root of b cubed is just b. And that leaves me with the cube root of b, right? This guy is stuck inside the radical. It cannot come out. But we have a problem. We don't like having cube roots or square roots or any sort of radical in the denominator of a fraction. And so we need to get rid of the radical. But how can we get rid of the radical? What can we multiply this term by to get rid of the cube root in the denominator? We can multiply by the cube root of b squared. When I multiply by the cube root of b squared, this b and this b squared will become a b cubed. So I would have the cube root of b cubed, which is just b. But whatever I do to the denominator, I must also do to the numerator. So I'm multiplying the top by the cube root of b squared as well. Okay, so this combo here simplifies to b. And so my final answer in simplified form, I would have a squared times the cube root of 12b squared, right? I can combine those two and put them into a single radical. And my denominator would be 8b squared. And that's my answer. It can be a little bit confusing at times, so we need to keep practicing. Keep practicing. Okay, here's another one. The square root of 15 over the square root of 500. We've got a square root on top, a square root on the bottom. We want to try and get rid of that square root on the bottom, but let's see if we can simplify and cancel things out. And so I'm going to factor each, right? The square root of 15 is the same as the square root of 3 times the square root of 5. Yes? And that's a multiplication. Okay. And the square root of 500, could that be written as the square root of 100 times the square root of 5? Yes, yes it can, right? Because 5 times 100 is 500. Okay, when you have the square root of 5 divided by the square root of 5, they cancel. So those two disappear. And we are left with the square root of 3 on top. And what's the square root of 100? That's right, it is 10. So we have the square root of 3 over 10 is our final answer. Okay, that one wasn't too bad. Let's try a more challenging one. Here we've got 3 over 4 plus 4 square roots of 5. And whenever we have a sum in the denominator with a radical in one of the terms, we have to multiply by what is called the conjugate. And the conjugate, and we have to do that to both the top and the bottom. So I'm going to put some parentheses there. The conjugate looks very similar to the denominator, or whatever we are trying to rationalize, but it has the opposite sign. So if this is a plus sign, this has a minus sign. If this was a minus sign in the middle, this would be a plus sign. The only sign that changes is the one in the middle, okay? And so on top, we will also multiply by 4 minus 4 square roots of 5. Okay, the first thing that I want to do is distribute. On top, we'll distribute the 3. So 3 times 4 is 12 minus 3 times 4 square roots of 5 would be 12 square roots of 5. Now, on the bottom, let's FOIL it, right? 4 times 4 is 16. 4 times negative 4 square roots of 5 would be negative 16 square roots of 5. 4 square roots of 5 times 4 would be positive 16 square roots of 5. Do you see where this is going? Those two are going to cancel. And then minus, because there's a minus sign here, 4 times 4 is 16. And the square root of 5 times the square root of 5 is just 5. So this will be 16 times 5, which is actually negative 80. So let's simplify this a little bit more here. We will have 12 minus 12 square roots of 5 over, well, 16 minus 80, because these guys cancel, right? 16 minus 80 is negative 64. And when I look at this, I think to myself, this can be simplified further, right? I know that 12 is divisible by 4, 12 square roots of 5 is divisible by 4, and 64 is also divisible by 4. So I'm going to factor out a 4 on top and a 4 on the bottom. So if I factor out a 4, I will be left with 3 minus 3 square roots of 5, right, over 4 times negative 16. Now, the 4's cancel, and I'm left with 3 minus 3 square roots of 5 all over negative 16. But this negative is a little awkward in the denominator. And so I can move it up top and just change the signs of everything in this equation, right? So this becomes a negative 3 plus 3 square roots of 5 over positive 16. And that is the simplified answer. Negative 3 plus 3 square roots of 5 all over 16. We no longer have a square root in the denominator, and it is in simplest form. Okay, I hope that you are well. We will see you next time.